The three laws of motion that we've learned so far are the foundation of all mechanics. But applying them in problem solving is where the real challenge begins. Problems usually don't involve a single object in isolation. They often involve multiple bodies, each influenced by forces such as tension, normal reaction, friction, and of course, gravity. When tackling such problems, the first key step is to decide what is my system and what is the environment. For example, if I choose a block sliding on a rough surface as my system, then the block is isolated while the environment consists of the surface, earth, and any external forces acting on it. This separation makes it easier to apply Newton's laws consistently. Once the system is chosen, the next tool is the free body diagram. Imagine removing the object from its surroundings and just drawing arrows for all forces acting on it. For example, on a block resting on an inclined plane, you'll draw the weight acting downwards, the normal reaction perpendicular to the plane, and friction parallel to the plane. These arrows allow us to see the forces clearly and apply equations of motion correctly. In more complex setups, like pulleys or two blocks connected by a rope, forces appear as interactions between bodies. For instance, the rope exerts tension on each block, and according to Newton's third law, the blocks pull back with equal and opposite forces. If you treat the whole assembly as one system, these internal forces cancel out. But if you treat one block as the system, you must include that rope tension in your equations.
So, what's the golden rule for solving mechanics problems? Step 1. Draw the free body diagram. Step 2. Resolve forces along horizontal and vertical directions. Step 3. Apply Newton's second law. Force equals mass into acceleration, separately in each direction. And step 4. Write equations for each body, then solve them simultaneously. Don't forget, constraints like equal tension in an ideal rope or equal acceleration in connected bodies simplify the solution.
Let's try an example. A 5 kg block is connected to a 3 kg block over a frictionless pulley. What is the acceleration of the system and what is the tension in the string? Step 1. For the 5 kg block, the equation is open bracket 50 minus tension close bracket equals 5a. Step 2. For the 3 kg block, the equation is open bracket tension minus 30 close bracket equals 3a. Solving these two equations, we find A equals 2.5 meters per second squared. Substituting back, tension equals 30 plus 3a, which is 37.5 newtons. So, the blocks accelerate at 2.5 meters per second squared and the string carries a tension of 37.5 newtons. To wrap up, solving mechanics problems is about careful organization. Choose your system wisely, draw the free body diagram neatly, apply Newton's law step by step, and use constraints cleverly. With practice, even complicated assemblies of pulleys, blocks, and strings reduce to simple equations. I hope you now see that solving problems in mechanics is less about brute calculation and more about clear, logical thinking. See you in the next session where we'll explore another exciting concept of physics.